All right, now we have some end behavior problems. So you're not asked to graph these. You're just asked to state the end behavior of the function. In this case, a sketch is probably going to be helpful, so that's how I'm going to tackle most of these. Just do a little sketch and then talk about the end behavior. All right, so for log of x minus 9, remember log of x, the general shape is going to be this guy. So we're only going to do end behavior in one direction, only toward infinity. So we're going to look, it's going to look something like this. As x approaches infinity, what is y going to approach? So this guy, this transformation is just right 9 units. So our asymptote would be at x equals 9. So as x approaches infinity, our y is going to be going up forever. So we're going to do y approaches infinity. And that's your end behavior for A. For B, here I have negative x squared. That negative is going to flip x squared down. So x squared is going to look something like that. So we can evaluate end behavior both as x approaches infinity and as x approaches negative infinity. So as x approaches negative infinity, here we're going down forever. Y approaches negative infinity. And as x approaches positive infinity, here we're going down forever. Y approaches negative infinity. So these end behavior problems are really just about knowing those basic transformations in your very most basic shape here of each function. C, h of x square root of 1/5 x plus 3. So square root moves up 3 units. And this guy is a horizontal stretch by 5. So it's going to be a lot longer. It's going to take a lot longer to grow. But we really don't care how long it takes to grow. We just care that it's growing. We can only evaluate this as x approaches an infinity, because x doesn't approach negative infinity. As x approaches infinity, so does y. It's growing forever. All right, e to the x. E to the x is kind of a tough one. So really, I would kind of do this one in 2 steps. I would do your basic e to the x graph. Remember that e to the x does not cross the x-axis. And then think about what so the 5 is going to be a vertical stretch. So it's just going to make it taller faster. This is the one that really affects things here. The negative with the x is going to be a reflection over the y-axis. So now, instead of, and I really have to think hard doing this one, honestly. So now, instead of from left to right, our function growing, when we flip that over the y-axis, it's going to look like this. And that really affects the end behavior here. So let's look at our end behavior now that we have this sketch. As x approaches negative infinity, y is going up. Y approaches infinity. As x approaches positive infinity, y is flattening out to 0, so y approaches 0. Those horizontal asymptotes are a big deal. They're a big deal for limits, and we will do that at the end of the year right before you have this. Okay. Cube root is a little easier. So cube root, we're moving it up, we're moving it right and up here. So we move it right 5, up 6. But that doesn't really affect the end behavior here. So as x approaches negative infinity, we're going out a lot faster than we're going down, but our function is still going down forever. Y approaches negative infinity. as x approaches positive infinity, again, we're going out faster than we're going up, but our function is still increasing. So y approaches infinity. Okay, f. 1 over x plus 2. So here, we're just moving our 1 over x function left 2 units. Our basic shape looks like this. And in both directions, since we didn't move this up or down, so in both directions, we're flattening out to 0. So as x approaches negative infinity, y approaches 0. And as x approaches positive infinity, y approaches 0. Because of that asymptote, it's never going to get there, but that's where it's going. Okay, there are just a couple graphs to do with end behavior as well. It's helpful, I think, to identify on these graphs or with these graphs what function you're looking at. Here with g, this is cube root. That's a cube root that's been moved and flipped. But and a fill in the blank is helpful sometimes too. So as x approaches negative infinity, y is going, again, out faster than it's going up, but it's going up. And as x approaches positive infinity, y is decreasing, so it's going to negative infinity. Another e to the x. E to the x is going to either be your worst function or your best. So you might as well like get to know it and make it your best friend. All right, so as x approaches negative infinity, let's see what we're doing here. So we know that e to the x flattens out, and it flattens out fast. So don't let the fact that the pixels on the picture aren't small enough mess with you. This y is going to 6. You have to know when you're looking at, you have to identify e to the x and know that that horizontal asymptote is there. And then as x approaches positive infinity, here our y is decreasing, our y is going to negative infinity. And it's going fast because it's an exponential. All right, last one. 1 over, this guy is a 1 over x squared with a transformation. Just then moves up. Similar with as what I just said with e to the x, you have to know with 1 over x and 1 over x squared, you have to know to look for these asymptotes. So here we have this horizontal asymptote at 2. So as x approaches negative infinity, we're flattening out to 2. And as x approaches positive infinity, we're flattening out to 2. Awesome.